everyone. Lucky Arduino here. Today I'm going to be talking about a special project. So, as some of my viewers know, I've been away for a month. I've been at Cosmos at UC Davis, which is a summer program, and I was in the cluster Internet of Things, which is basically a cross between electrical engineering and computer science. So, me and my partner, we made a project called RiseNRun, and this is us. Um, So let's go through our project. Basically, our motivation was that we're having trouble waking up, so we would just drop the alarm and go back to sleep, which would make us late to class and also sleepy. So we wanted to make something that would solve that problem. And I'm sure many of you guys also have this problem. So our original idea was a spiky shelled robot, which was like you would have to run after it and get hurt a little bit, and there would be spikes all around to make that happen. Once you would do something like lift it up or touch it, the shell would open up and you would have to do tasks. It would have Wi-Fi communication and all the parts would work as intended. And this was our final result. As you can see, there is no shell, but we did implement the Spiky Slapper 3000, which is the hand that you can, that you can see right here. Um, of course, this is a prototype. Uh, for your guys' purposes, let's just go over some of the parts here. So this is our robot. Um, we have an MSP 432 inside this robot where that's our microcontroller. Instead of using Arduino, we use that. And then we have a booster pack on top with this joystick and a couple of other things that just provide us with more ports and height on the robot. Um, then there's also this robot kit with the wheels, as you can see right here. That's the outside of it, and that's what helps the robot roll around. Um, we've got this breadboard set up here with the touch sensor, three colored buttons, a buzzer, and a dial, which is a potentiometer with a cover on top. Over here, we have a servo setup that you can't see, but that's what helps the hand go side to side, which you'll see later. There's also no Wi-Fi communication. We wanted this, our intention was to have like an app that would set this up, but we weren't able to implement that, and you'll see why later. So here we use some 3D printed parts. We have the hand obviously, which was made with Tinkercad, and then we also have the breadboard support, which if you go back, you can see it's right under the breadboard right here. So that's what we needed for this project, and
I'm so tired. Let's use our Rise and Run to set an alarm for tomorrow so I'm not late for lab. Oh my god. All right, let's do, I think this should work. This time is perfect. And let's set it at 60% of its speed. We want it to be quite fast. All right, time to go to bed. Oh, oh, stop. All right. Let's see what we can do to stop this. It's so loud. Oh my god. Fully twist the dial left. All right. Boom. Press the green button. All right, let's press the green button. Fully twist the dial right. Okay. Thank you. Now I can wake up and go to lab. All right, let's show off some of the capabilities that our Rise and Run has. So obviously we can set our timer here. Let's set a small timer so to show it off. Let's set a small speed because we don't want it too fast. So this is 3 seconds. All right. Yeah. All right. Now this also has joystick capability, so we can do up, down, left, and right. This one is up. Okay, it's asking me to do it right. Let's do it right. Okay, let's do it up. Boom. And now we can do it as many times as you want. You have a history of your Rise and Run, so you can see what tasks you did yesterday.
thank you. Yes, so that was our coding. Let's go through some of the challenges that we had as well. So these are the hardware challenges. We have the red button, which just drained voltage from our microcontroller, and we couldn't. It just made our other components stop working, so we had to replace it. We also had the potentiometer. For some reason, the manufacturer decided to wire the yellow wire to ground and the black wire to signal. Not sure why. But that messed us up for a while. We accidentally blew up two potentiometers out of the three that we had. So LCD screen doesn't work with the RSLK kit. We had to figure both that out. But it is what it is, right? We work with what we have. And then these are the software challenges. We importing libraries was very fun. Um, so fun, as you can tell from the sound of my voice. Um, Basically, I had to find libraries for the robot kit and put them into like 10 different places. And then I figured out that three of those places were the best place to put them. And then it worked, but that took 3 days to figure out. Then we had the Wi-Fi, which didn't work in the labs that we did in class, and it also didn't work in our project, and so we just weren't able to implement it. Uh, yeah, and then we had port issues with the robot kit. Once we implemented that after 3 days, we had to change around all our ports because the robot kit used some ports that we needed. So yeah, and then the serial monitor ports. My computer has one COM5 port and one COM3 port. The serial monitor was reporting that I had 20 of each. So yeah, that was some issues. And what we learned from it, we from the class as a whole as well, we learned about software, hardware, and the physics behind certain components. You can see the description on the screen there. And before Cosmos, we knew nothing, but after Cosmos, we learned a lot.
All right, let's get into some of the code that we used for this project. So as you can see, this is not the Arduino IDE. This is actually Energia, which is the coding platform that we had to use to code our MSP432. But it mostly stays the same. We can use the same functions as Arduino, etc., etc. So here we start with the libraries. Um, Here we have the servo library. We need that for the hand. Uh, STDIO, which is the input-output library. Um, and then the driver library, which helps with downloading different drivers for the MSP. Here are the robot libraries, which, to be honest, I can't really explain. These caused a lot of problems for us, and I'll get into those problems later. Um, Here we have the some variables defined for um, ease of readability of our code. Here we start our servo. Um, these are just setting different things as inputs and outputs, setting up the robot also, and generating a random seed for the random number generator that you'll see in a second. So first we start with setting the timer, which you saw, and then setting the speed, and it takes those values, sets them to variables. Then it counts down the timer and prints it to the serial monitor. Um, so after that, once the timer is done, it exits the for loop and the motor starts up based on the speed that you gave it. Then it goes into this while loop. So while the touch sensor is not detecting anything, it will keep repeating this. The spiky slapper 3000 writes to one direction. Then we use the buzz function 1000 times. I'll explain this in a second. Let's just get to the rest of it. Then the hand goes the other way, and then the buzz's function is repeated 1000 times. So let's go down to the buzz function. I'll explain that. Um, Basically, the buzzer is high for 250 microseconds, and then it's low for 50 microseconds. Basically, what this means is that um, it will take this function takes up 300 microseconds of delay. And if we go back up here, you'll notice we looped it 1000 times, right? So 300 microseconds times 1,000 is 300,000 microseconds. That translates to 300 milliseconds. And using this, using this for loop, we can cause a delay of 300 milliseconds, which is what we found to be the most optimal to move our hand around. And that allows us to keep our keep our buzzer going while the hand is also moving side to side. After the touch sensor is pressed, we stop the motor, and then we count to 3 for the 3 tasks. So we generate a random number, we print that number, and then we send it into the task generator function. Let's look at that. Let's take the first number as an example. So if the randomly generated number is 0, it'll press the red button as the task. Then it waits while the button is not pressed, right? So since we set the button as input pull up, that means that 1 is off and 0 is on. So while the button is off, keep buzzing, right? And that's basically the gist of the code. And that's what happens with all of these. Press the blue button, press the green button, dial right, joystick up, joystick down, joystick left, joystick right, dial left, right? And we're just checking. So while these aren't true, the while it's true, you keep buzzing, basically. And then once the 3 tasks have been finished, turn off the buzzer. And then you go back to the start. Since this is void loop, you just go back to the start, and the next night you can do it again. And that's the code behind our project. Let me explain some of the problems that we went through.
Yes. So in class, we did a live demo of this. Um, so basically, the premise of this project, if we go back, we remember that it was to wake up, right? So the steps for this project, first, we would set the timer and the speed as you saw in the video. Then you would go to sleep and it would start moving around and slapping you once it was time to wake up. Once you did that, you would press the touch sensor to turn the robot movement off, but the buzzer would still keep buzzing. So that then you would have to do 3 tasks to stop the robot entirely, and then of course you have your history so you can save it for later. Let's go through the code as well. There's a live demo. Thank you guys for watching. I'll see you in the next one.